Welcome, kids. Today we're talking about qualitative solubility with curves. What does qualitative mean?
So qualitative, I know, is describing something with words instead of numbers.
Okay, which would be quantitative.
Yeah.
Okay, so we're going to do qualitative today. Okay, so what is solubility?
It's the ability to dissolve a solute in a solvent to create a solution.
Awesome. And we're going to talk about curves like this one.
Awesome.
So there's three words on your solubility curve here. You have saturated sorry. Okay, we have saturated, supersaturated. Which is the word I really want you to pay attention to there is supersaturated, saturated, and unsaturated. So let's talk about what each of these means.
Okay.
So let's talk about saturated first. So saturated corresponds to this line. We're looking at potassium nitrate, okay, at different temperatures, and how much of it, how many grams of it we can get to dissolve in 100 grams of water.
Okay.
So you notice as the temperature goes up, what happens to the solubility?
As the temperature goes up, it looks like you can dissolve more and more of your substance.
So we dissolve, the amount we can dissolve goes up. Okay. So saturated means that the solution is saturated, or it's dissolved as much solute as it can take in. So we can't get any more in under normal conditions.
Okay.
So on the line, it's saturated. Okay. Unsaturated means we can dissolve more, and we call this dilute. Have you ever had an iced tea that's had a lot of ice cubes in it?
Yeah.
It's dilute.
It doesn't taste very good.
Okay, so unsaturated means we can dissolve more. Supersaturated means it's over the limit or oversaturated. So it's oversaturated, and this happens when we do certain things to solutions. Okay. So like a soda is supersaturated because there's way more carbon dioxide bubbles in the liquid than would happen under normal conditions. So it's under a lot of pressure, so it holds on to more gas. But once you pop it, all the gas escapes.
So if you radically change the temperature and pressure, you could get more solute dissolved in your solvent than you could under normal circumstances.
Yeah.
All right.
Can you think of something that's yummy that's a supersaturated solution?
Rock candy?
Yeah. So rock candy is made by creating a supersaturated solution, more sugar than would normally dissolve. So now, let's talk about the fun part, math problems.
Yay, math problems.
Okay, so the first one we looked at was just potassium nitrate, one curve. Now we're looking at a whole bunch of solutes.
There's a lot of stuff on there. There's a lot of stuff going on.
Yep. So now we're looking at a whole bunch of solutes on one curve.
Okay.
Read it the same way. As temperature goes up, solubility goes up. And keep in mind as we're going through this that we're looking at 100 grams of water. You can see here.
Okay. So everything here is grams of solute per 100 grams of water.
Yeah.
Okay, very important to remember.
Okay, so describe the solution of 60 grams of potassium nitrate are dissolved in 100 grams of water at 40 degrees C.
Don't I just treat this kind of like a graph and just plot the point, right?
Exactly.
So
here's my 40.
There's 40 and 60 up on the y-axis over there.
Well, let's do 40 degrees, and let's look to see how much potassium nitrate can dissolve at 40 degrees. So we're right about here.
So if we're at a point on the curve, we're saturated.
Mm-hmm.
Well, it looks like 60 grams per 100 grams of water of potassium nitrate at 40 degrees is right smack on that line.
Yep, so it would be saturated.
So we call it saturated.
So if we had 80... it would be supersaturated.
Because that'd be above the curve.
Mm-hmm. And less than 60
would be unsaturated because it's below the curve.
Exactly. Okay, let's do another one. So 20 grams of cerium sulfate in 100 grams of water at 80 degrees, and 17 have collected on the bottom.
So that means 17 of the 20 grams did not make it into the dissolving in the solution.
Right. So that means I poured 20 in. Mm-hmm. Only 3 of it dissolved.
Okay, 3 grams dissolved at 80 degrees. Cerium sulfate's one of those ones that's kind of weird. It doesn't follow the same rules. Mm-mm. As the temperature goes up for cerium sulfate, that's the curve on the very bottom, it actually goes down in solubility. It's like one of the only ones that does that. So let's see, at 80 grams,
degrees, it looks like
we got
over here, about 3.
Yeah, so about 3 grams will dissolve at 80 degrees Celsius, leaving 17 at the bottom undissolved. So that's just a saturated solution,
So
right?
it's saturated, and then, yeah, the rest of it's
It's
on the
got
bottom.
extra at the bottom. So if we had said 20 grams of it
Mm-hmm.
did dissolve,
Then it would be super
then it would be
saturated.
super saturated, but only 3 of the 20 dissolved in this
Right, so
case.
you have to pay attention to how much is actually
Yeah.
in solution or dissolved. All right, let's do one more.
Speaking of reading the question carefully,
Okay, so
here's one.
now 20 grams of ammonium chloride and 50 grams of water. Now remember, our curve is based on 100 grams of water. So you can still use the same curve, but it can only take half as much.
All right, so
50 is half of 100.
if 20 grams is dissolved in 50,
Mm-hmm.
that means it would be 40 grams per 100.
Right, so 40 grams per 100 H2O. Let's write it like that.
Okay, so this is really looking at, let's say we have, and this is the way we can read it on our actual graph, is to make it to where our graph can read it. Okay, if we have 40 grams of ammonium chloride,
okay, so let's find, so
at
we're looking
70.
at 70 degrees, and we're looking at ammonium chloride, we're right here. So to be saturated, we need 60.
Yes.
We have 40.
So where's our
Under the
point?
curve,
We're below
so
the
we're
curve.
here.
Oh, so we're below that curve. We're not
Mhm.
looking at any other curves except for ammonium chloride. And so yeah, it's below the curve, so therefore unsaturated.
Yep, so it's easiest if you say, okay, 50 is half of 100, double the amount
Right.
to make it equivalent.
Okay. That seems really easy. This is just like graph reading 101.
Yep, that's it.
Can you do it? Can you read the question and make sure that you don't get tripped up with those 20 grams per 50 grams of water? You just really got to pay attention to these questions. I think you'll do fine.
Yep, sounds good.